Hello and welcome to our exclusive webinar on Mastering Industrial Device Connectivity, PROFINET, EtherNet IP, EtherCAT, Cybersecurity, all presented to you by HMS Network. We have a great turnout today. I'm seeing people from the US, Belgium, France, the Netherlands, Switzerland, Croatia. So it's going to be an exciting session. I'm Brian Tristan Williams, editor for Electro Magazine, and I'll be your host for the session. In the world of industrial automation, seamless communication between devices is crucial. So today we'll have a look how to efficiently implement these communication protocols and address the growing importance of cybersecurity in our industrial networks. Our goal is to provide you with practical insights and proven techniques to streamline your projects, enhance security, and future-proof your systems. So I'm thrilled to have with me three industry experts from HMS Networks. We've got Kurt van Buul, OEM Project Manager, Thierry Bieber, he's the Industry Manager, and Andreas Johansson, Field Application Engineer. How are you doing, guys?
We're doing well. Hi.
Great, thanks.
Excellent. So with their extensive experience and deep knowledge, they will guide us through the complexities and best practices of industrial communication. And let's begin with Kurt, who will introduce us to Anybus Compact Com. But before I do, I just want to remind you, it's a very busy chat room. Please drop your questions as the presentation is going, and then we'll answer in a Q&A session afterwards. Over to you, Kurt.
Thank you, Brian. And welcome, everybody. My name is Kurt van Buul, and I will start the webinar. Andreas will take over, and after that, Thierry will present. Before we start, I would like to introduce to you HMS. HMS stands for Hardware Meets Software, but that's the name of the company. We do have four brands. Anybus, what we will discuss today, is everything about industrial communication. E1 is about IoT and remote access, and TASIS is about building automation, and EtherCAT is about in-machine and safety communication. In the world of industrial communication, we are quite large player with millions of devices already shipped, and 500,000 of IoT connections we support for our customers. And we are in the forefront of 5G, smart grid, and IoT. In total, we have 1,200 colleagues all over the world. We produce mainly in Europe, and our headquarters is in Halmstad in the south of Sweden. Today, we will discuss our product Anybus Compact Com, and we discussed Anybus Compact Com already in depth in a previous webinar. But for those who were not possible to participate, I will introduce Anybus Compact Com shortly. This whole webinar is about enabling industrial communication, or to say differently, to connect the slave to an industrial controller. You're developing an application, some electronics, and you want to connect it to an industrial controller, and that normally you do over all well-known industrial protocols like these ones, but there are many more we support. And besides an industrial controller and industrial communication, is communication to the cloud also very important. And that is normally done with OPC UA and MQTT. And to connect to an industrial connector to the cloud, you need to have a communication interface. And Compact Com is all about a complete communication module to connect you to a host CPU to the cloud. It comes in two form factors. The first is the M40, which is an all-in-one module, and as you can see, it includes all connectors needed. On your printed circuit board, you design in a slot and a connector, by the way, a compact flash connector, and you simply slide in the module. And that can even be done by a user, which gives you the possibility to have communication available as an after-sales option. Secondly, we have a brick, a plug-on form factor, small printed circuit board, where you reserve space for on your main printed circuit board and mount the small PCB. The main difference between both is that the B40 comes without connectors. So connectors and magnetics in case of Ethernet, you have to adopt to your printed circuit board. This gives you the possibility that the freedom of selecting connectors, especially if you want to make water resistant or completely waterproofed solutions. It works according to the host and master principle. The host is your CPU on your micro on your application platform, and again we slide in an M40 module, and with help of a software interface we provide, you can communicate with CompactCom. CompactCom will communicate with the master controller, the PLC, or the target industrial controller. And therefore, such a controller needs to know the characteristics of your application. And the PLC programmer knows that information by loading an EDS, that's the generic term for electronic data sheets, or protocols use different abbreviations. And you can extract an EDS from CompactCom, so the PLC programmer has one-to-one information about the characteristics. And the main concept of CompactCom is that you exchange from your microcontroller to CompactCom the information you want to exchange over the network. In this case, you would provide to the network temperature, status, and RPM, and you expect commands back. Everything about communication, data packaging, networking is handled for you by the module. And that means that the master PLC will pre-program CompactCom before starting, and has the possibility to use these variables as a menu chart. So a master programmer can say that he needs the temperature and the status, don't want to use the RPM, and of course send commands. That everything doesn't influence your application and is handled between the module and the master PLC. How does that work in practice? Let me give you an example with PROFINET. I insert an M40 for PROFINET. Again, I'm exchanging these variables. And then on the side, I have a CMOS PLC receiving these values and sending and connecting via the standard PROFINET industrial interfacing. At the moment, I exchange the module by an EtherCAT. Again, I'm exchanging exactly the same variables. There's nothing changing on my application side, but everything is changed on the outside, because now I'm connected to a backup PLC, and I'm communicating according to the EtherCAT industrial structure. How do you design in these interfaces? Well, to understand how CompactCom works, I first introduce you to the main component, and that's our MP40 chip. And the 4 in 40 indicates that this is our 4th generation, because we started with these type of interfaces already 25 years ago. And of course, we have a secure element chip for secure boot and secure IoT, but that we will discuss later. This MP40 chip contains of an ARM Cortex M3 microcontroller, completely focused on communication, and a large FPGA fabric. And in this FPGA fabric, we download the low part of the network. So in the case of the PROFINET IoT I showed before, you will find a complete real-time Ethernet switch, including IEEE clocking and everything on timestamping what is used by PROFINET. At the moment you are using EtherCAT, you will find in the FPGA fabric the complete typical EtherCAT input and output of message, data exchange of messages. And even the lower part of TCP IP stack, when used, we program in the FPGA. On the microcontroller, we run a real-time operating system, the stack to handle the complete network according to the network standards, and an API. And the API is the standard application interface that communicates with the host application, so with your microcontroller. And this all comes in one firmware package. On the hardware side, the MP40 chip, of course, has to connect to the network of choice. In the case of an M40, that's already done for you. And in the case of a B40, you have to implement it on the printed circuit board. And for Ethernet variants, that will be a connector and the magnetics. And for the field bus variants, is the typical field bus to logic converter, for example, 485 converters or CAN bus converter, and of course a DC-DC converter to isolate the network. On the host application side, we have a common application interface. Of course, where you exchange data to the microcontroller, and you have the possibility to exchange data parallel. We support both 8 and 16-bit via SPI or via serial. And with help of some data mode lines on the chip, you can set up the data mode you prefer. For flow control, we support reset and interrupt. And please note, reset is an output from your microcontroller and is not connected to the reset system of your microcontroller. So you have the possibility to reset communication and reset the module without interfering the application. Furthermore, you can detect and identify the module if you want, and of course you need a power supply. In the smallest interface version, you can go for SPI, reset, and power supply, and you're ready with 7 connections between Compact COM and your microcontroller. I already indicated before that it comes with a software interface. And the software is an OS-independent C driver interface software. Avoid the word driver doesn't mean that it's in the kernel or something. It's plain C, and you can use it in operating system environments, but also in applications without an operating system using an independent loop. The first layer of our software is the adaptation layer. For example, you find here the keep alive entry, and also the interrupt entry is already available. Important for your application are the ADIs, the application data interface, or the variables I already showed you before. The next layer contains the objects, and it's gray out because it's still C. You can see directly what's happening, but it's not the intention to change. We will update for you. Compact COM is completely object oriented, and here are the copies of the objects you are using at the moment. In the driver part, everything is set up to send and receive data from to and from the module, and of course that's for serial, parallel, and SPI connections differently. And last but not least, you have to set up the low level. You know how you have connected it to your target hardware, so you have to set up on a low level exactly which SPI you are using, for example, or which I/O pin you are using for as a reset. That makes the complete C interface software. One small word about ADIs, the variables you are defining. I would give you a brief example of an application where we have a tower light with 5 colored lamps and a robot arm. And with some hardware, it's connected to CompactCom. In this case, we would define 3 ADIs. An ADI has always a number. The first we call tower light, and is an array of 5 Boolean, 5 bits, and the data direction is read. We read from the network. And the second one is the position controller of the robot arm. It's an array of 3 D words, so 364 bit words, and again it's read from the network. And the last is the status, and that's written to the network. Of course, that information is sent and received from the master controller, and how that exactly is done is depending on the protocol you are using. ADIs will be set up in slots and subslots when you use PROFINET, or PDOs and SDOs in sub-indexes when you're using EtherCAT, PowerLink, or CAN Open. In reality, that will be abstracted by the generic ADS file, which simply support the master programmer in exchanging end-to-end information to your target application. After this introduction, I would like to hand over to my colleague Andreas to show the interface in practice.
Thank you for that, Kurt, the introduction on the CompactCom. So what I'm going to demonstrate now is how to use this host application, or the driver that Kurt was explaining. For this, I have with me a Raspberry Pi. I also have an adapter board for the Raspberry Pi. Oh, it's blurry. And then I also have one CompactCom. So what I'm going to do is I'm going to insert the CompactCom in the adapter board. And I will then position the CompactCom like this. So now I have it plugged into my Raspberry Pi. And if I share my screen now, you can see that I have my Raspberry Pi screen up here, and on my Raspberry Pi, I have this driver that's provided from HMS for the CompactCom. And what I'll do is I'll go into an example application. I'll choose this speed example where we emulate a motor, and it will open up like this. And the first thing I would like to show is we have set up 2 parameters here. One is a speed, let's say the speed of a motor, and a reference speed that's going to be sent by a PLC or a master. And below here, I have a simple loop that accelerates the motor if the ref speed is increased, or decelerates it if it's decreased. What I can do then is I can run this application. So I just go into this folder. And I can start by compiling the code. and then I can run this code. And here you can see that the CompaCom starts up. What I can do now is I can open up another window on my computer. This is on my Windows computer. And I can search for the IP address of the CompaCom. So for this, I can use the HMS IP config tool. And here we can see that my computer finds the CompaCom, which I have connected via the Ethernet port to my computer with this IP address. And I can then surf into the CompaCom's internal web page, where we can see that this is a CompaCom for the Ethernet IP module. This means that the CompaCom is running the Ethernet IP software stack at the moment. We can go to parameters, and here we can see those two parameters that I configured. If I, let's say, increase this reference speed, I can set this from the network. We'll refresh. We'll see that the speed follows. It's quite fast, but if I refresh multiple times, you can see that it's increasing. If I go a bit higher, you can set it. It's increasing like a motor. Oh, the web interface is not showing.
Yeah, it seems to be one of those screen sharing glitches.
Okay, that's unfortunate. Should I try to stop share and try share it again?
Yeah, try to share a different window. We've got a lot of questions, and thank you guys for pointing that out.
Yes.
Questions coming in from all over the world. I see some of our French people are saying bonjour. I thought it was bonsoir at this time of day. Okay, there we go.
I'll start over. I'll go from the beginning. Here is the IP config tool. Or you can see that. All right, I'll just try to surf into the web page of the CompaCom. So I found out that the IP address is 192.168.0.10. Here we can see that this is an Ethernet IP module. I go to the parameters, and here I can see that the parameters that we configured is shown up. And the speed of the motor is right now really high, it's 65,000. If I then change the reference speed to 0, I want the motor to decelerate, and I can refresh, and you can see that it decelerates. And now I'd like to show my Raspberry Pi screen again. So I can maybe stop sharing and try sharing again.
Yep. And we're
there we go. I'll stop the program. I'll go into this the code, and I'll add another parameter. Let's say I want to add a temperature. So I'll create a variable. Let's call this temp. And I will just copy this one. I'll make this the instance number 3, temperature. I call it temperature. Let's keep it as a uint 16 and I'll then add the address of the variable, and I'll make it readable from the network, because it's the temperature of the motor, so it should be readable and not writable from the network. What I'll do now is I'll recompile. I'll run the program again so the CompaCom starts up, and I'll stop sharing and start sharing my other screen from my computer. And there we can see that this temperature has now appeared on the network. Yeah, it's very simple to add parameters and test out your data on the Raspberry Pi and try out different features of the CompaCom. So that's what I had, and I'd like to give over to Thierry.
Good, thank you, Andreas. It was a quick presentation in order to show you in fact, how where is your focus, and how we can really convert your ideas into something that is flying quickly in terms of industrial communication. Don't see my screen on the perfect. Yeah. So this is where we want to help you to convert this your ideas into something that is flying, means for industrial protocol something that is reliable, that is quickly made, and where you focus on your own application, your own competences. This is in fact what Andreas showed you, is you just need to create the structure of your data that you want to share, and the rest of the industrial protocol, the rest of the communication stuff, which are specific to each protocol, we are taking it over in charge. You have a QR code here if you want to go one step deeper in the integration layer. We have there an e-learning sessions where you can get the more details about the concept of the Anybus CompaCom interface, about the ADI, the object elements that you are creating on your host application, or as well about our starter kit, about our documentation, everything that you can need in order to have a quick start with this with this first step. But this is what you need and how you start your first step with the industrial communication. But we see more and more that in the industrial area, there are some additional challenges that are coming on the device maker in terms of communication. New requirements in order to share the data to a higher level, to IoT application, to get more information at this level, to get to increase, to optimize the industrial processes, and nowadays additional requirement in terms of cybersecurity. And once you design an industrial solution, you want to get your device or your communication to be future-proof. And let's see quickly about this next step, how we can support you. And starting with this, a little bit more background about this new requirement. There are a couple of changes that happens on the industrial communication, and all these changes happened in a so-called decade cycle. We had the serial field buses that were quite present in the year 2000 with technology like PROFIBUS, a strong push and an introduction of EtherNet-based industrial communication with a transition from PROFIBUS to PROFINET, EtherCAT as an example, in the year 2010. But now, as we have a lot of our industrial networks being on an Ethernet infrastructure, all these industrial, the demand is to get more data out of these industrial devices. And now these new topics, IT/OT interaction, IIoT, or Industry 4.0, which is the next industrial revolution, is pushing at a very, very fast pace, new expectation on communication, faster communication on the device, and faster. I mean, especially in the rhythm that the new technologies are coming, and the customer's expectations on these automation devices to support as new communication. So we have here a faster need for data, so it means a faster need for communication, and where traditionally all these field buses were running at 100 megabit per second communication, and that were designed for that to guarantee determinism in the communication at 100 megabit per second. The need for gigabit is coming, especially now from the automotive industry, which have a large number of devices in their plants, and as well a stronger need for real-time, and real-time not only inside of the plant, but as well across the production line and across the production plant. So new mechanism like TSN, time-sensitive networks, as well needs to be implemented in devices to guarantee this real-time communication across the different infrastructure. If we speak about communicating with the IT, we do not speak anymore with just the PLC, with an industrial network, but we need new protocols that are combining more information, that are combining the value with a little bit more meanings, with a bit more context. And this new protocol, OPC UA and MQTT, are required. And even more and more, there is as well the option of the need to share not only the data internally in the factory, but as well with cloud applications. So new requirement in terms of IoT integration. Where are the data today located? The data are located still strongly at the sensor level, in every sensor that you see at the production side. So it means the sensors are important to be as well, to be able to send their own value in a very cheap and effective way. And new technology like APL, Advanced Physical Layer, or SPE, Single Pair Ethernet, to Ethernet-based communication, but the bus physics is slightly different, are as well coming and pushing with new ways to interconnect in a cheaper way on this in every devices on the factory floor. And as this Ethernet infrastructure are getting more and more critical in a production process, the network quality and the infrastructure uptime is highly critical. So that means it's very important to monitor, to support diagnostic function, and to cyber secure everything. And let's spend another point about cybersecurity. Cybersecurity is not anymore just a nice to have feature, but it is now getting a mandatory feature. There are new regulation, like for example the NIS2 regulation from the European Union. It's already in conversion in the different countries to be applicable. If I remember, I think starting from next year. And this NIS2 regulation defines the cybersecurity expectations for 18 dedicated industry sectors, like, for example, energy infrastructure, energy management, water infrastructure, but as well food and beverage industrial applications. They are now in charge or required to set up cybersecurity risk evaluation, cybersecurity risk management in their companies, not only at the IT level, but as well addressing the OT level. They need to declare the different incidents that happened in their factory, but they are as well responsible. So responsibilities and penalties has been defined. So it means companies that are not complying to these expectations will get penalties. So that means the industry segments or sectors will specify dedicated cybersecurity expectations to their suppliers. And in parallel to that, and it's quite new, the Cyber Resilience Act is another European regulation that will impact the device themselves. And here I'm speaking about the product, the physical product, or the software product that will be commercialized in Europe. All the products that have a digital communication interface, they will need to address the cybersecurity on all their communication interfaces. And this means, and this will be applied from 2027. All devices sold in 2027 and further will need to have the cybersecurity address. So it's on our product development scale, it's tomorrow. they will need to address the cybersecurity not only to be solved, but as well as a device maker, you have as well the responsibility to get this device sold 5 years long cyber secure. So you have as well an obligation to manage the cybersecurity during the life cycle of this device. So strong new regulation, strong new IoT impact on these devices. And if you were in the first webinar, we were speaking about these different stages that are required when you design an interface. And this is even more critical now with this multiplication of technologies that you need to implement. Just selecting the hardware platform that you will take for the communication interface will have a strong impact on the two main elements, the software implementation. And if you take standard chips where you need to implement a stack, and to get the stack reliable to pass the whole testing, certification, conformance certification, will here imply a lot of effort here. But as well, what is often underestimated in the second phase, the maintenance, to get this design reliable on every implementation on every production line and combination that you can find by customer, and especially keeping that up to date in terms of all the latest evolution of the industrial protocols. But now adding the cybersecurity is adding an additional layer on every stages of your design process, and as well maintenance phase. So that means complexifying and increasing the efforts on the whole implementation project. So again, here for these two different elements, IoT implementation and cybersecurity, we want to simplify this challenge for you. And as you have seen that prior in the presentation from Kurt, and as well explained by Andreas, that how you can, in your host application, create your variable, and we take in charge the communication to the PLC. The same thing can happen for your IoT interaction. Our IoT and secure modules implement next to the communication technology, the industrial protocols like PROFINET, an OPC UA stack, everything again embedded in the chip. You just need to define which of these items will as well be connected to the OPC UA communication channel. And the second thing that you can do is, as these OPC UA technologies are very good, their core value is in presenting the data, in structuring the data in a different way that is required in a PLC. We give you as well in our module the capability to build your OPC UA information model with this information, so that you can really have a nice way to present this to any IoT application requesting this information. So that's everything is embedded. You just need to reassign the existing data, or you can create, as Andreas had showed you that to you, new item that will be new ADI that will be dedicated to the OPC UA communication. So all built in, and this is exactly the same thing for the cybersecurity topic. As Kurt has highlighted in his parts, we have implemented dedicated security chip, TPM chip, that is hosting a hardware certificate, that is as well storing the certificate used for the different industrial communication. All the different components, firmware configuration files are assigned so that we can have a complete root of trust and the secure boots implemented in this module. managing or addressing any issue about counterface, about addressing the authentication of every items. We have fully implemented a certificate management, a user management, addressing the access rights for people that have the capability to configure via the web server, and as well all the different communication are secured, and the web server, as you have seen, would then be HTTPS. The firmware update would be as well via secured communication interface, and as well the industrial communication like PROFINET or EtherNet IP would as well run their own cybersecurity profile. So for security, which is available since a bit longer, this is already implemented and close for release. And on PROFISecurity, where the specification has been released, I think lately, the latest update was last month, we are as well in the implementation process to provide PROFISecurity. So all that is designed from our engineering team, which are as well certified against cybersecurity. Here we have an IEC 62443 certificate for the design of this product. So that means it's this IEC 62443 is a very well-recognized security standard for the design of OT devices. Means devices which are dedicated for industrial automation application. So again, all is built in as for IoT, as for the industrial communication protocol and the cybersecurity. So that means you don't see a lot, and you don't need to have a strong expertise in every of these elements in order to benefit from it. We take everything in charge. So it means what our customer that are implementing this our solution tells us that they are, by the first development, saving approximately 70% of their development efforts compared to a stack implementation, to an own implementation where they implement the stacks. And this for the first industrial protocol that they have done. All the further elements, all the further industrial protocol, like Kurt was showing you for EtherCAT, the transition from PROFIBUS and EtherCAT is up to 90% development effort savings, because you have already implemented interface, it's just exchanging the module. But now, with this next level, with our Anybus IoT secure module, we don't only get your device industry ready, but we get it as well IoT ready. So it means everything is on board. The expertise is very reduced. Everything is already pre-implemented and pre-certified. So it means it's compliant to the different specification of the network. So that means reduced risk on your side, and you have a planned project cycle or project plan, and as well planned cost for your development. What is very important, you focus on your core competences. You don't need to learn a new protocol, PROFINET, EtherNet IP, all the specificities of that. You just need to know where are the data that you want to share in your host application. And as Andreas were showing that, you declare it in our interface, in our software interface, and you define the link in your host application where our software interface can get this information. And so you get a faster time to market in order to release your device with industrial communication. The next step is, as you have implemented here a product which have everything on board, we are taking care to get this what is on board always up to date, always compliant to the latest expectations of the protocol, but as well of the market. So that means you have on your side an optimized product lifecycle just updating the firmware of the device, and you have your device running, and you have your investment in this interface protected for a longer time. Because as well, if there are new technologies coming in the market like APL or SPE, which is still in the specification phase, once this is clearly defined, we will supply you with a necessary interface module. So that means for you, it's as well a very fast way to innovate and to adopt this new technology. So that was it as a summary from my side. Again, here you get your our contact details if in the case you want to contact us. And again, the QR code where you find all the different links and e-learning platform, sample code to download if you want to start with testing and evaluating our solution. And we are now available if you have any further questions to answer all your questions. Brian?
Yes, thank you, Thierry and Andreas. We do have a few questions. I'll start with Roberto, who asks, how can I get one of the Raspberry Pi adapters and an Anybus module to evaluate it?
Yeah, maybe this is something that you can find the part numbers and the order code on the web page that I was sharing before. And yeah, you need as well to define the Anybus module that is related to the communication protocols you want to implement. On our website, you can find the different suppliers, distributors, or different offices that we have in the world wherever you are. But maybe what we can look as well is if you use our contact or my contact information detail, maybe I can look for a special offer for the participant of this webinar. So just send me your request on thbi at hms.se, and I can look what I can figure out in order to support the different people that wants now to test this solution.
Could you spell that email address, please, so we could get it on screen?
THBI Tango
THBI
TH
Hotel Bravo India.
Yes. Beta
Okay.
India at hms.se. SE for Sweden.
Great, thanks. Just want to get that up there. That's the address that you need to contact for assistance with that. Now, as for further comments, I've got a question from MS. Can we implement multiple industrial protocols in the module?
Yes, and I can combine that with the first question. If you order a Raspberry Pi adapter board, you also need to order a CompaCom with the network of choice. And I would suggest there to order our common Ethernet version, which is a CompaCom that you can run all of our Ethernet-based protocols on. So HMS supplies the software or the firmware with the protocol stacks that runs on the CompaCom. And if you order this common Ethernet version, you can run PROFINET, Ethernet IP, Modbus TCP, etc. All of the Ethernet-based networks. So that's a good CompaCom version to start with if you're ordering the Raspberry Pi adapter board. And I'll also drop a link in the chat here to where you can get started with the CompaCom and find more information about the starter kits and Raspberry Pi evaluation and so on.
Great.
So in
Kurt,
summary,
we're not getting
multiple
audio
networks.
from you.
Yeah.
Please note that CompaCom only support one protocol at the same time. If you want to use multiple protocols, you have to set up your environment in such a way that before CompaCom is starting up, you have downloaded in CompaCom the right firmware of the right protocol.
Yes.
Great, very versatile. Question from Jay Todd, who says he comes to us from the moon for some reason. Do you have pre-made profiles like CIA 402 for power drive systems, or does the user have to create all the application variables?
At the moment, this is for the user to create their specific drive profile, for example. So that's not something that we supply right now, but could be in the future.
And please note that when you use profiles in EtherCAT or can open, some variables have to be on the right location, and that you do by selecting the right ADI number for the right variables. So it's a small administration, and then you're completely ready to support any profile of your choice.
Another question from M.I. Are there any training and resources available for CompaCom hardware?
At the link that we supply with the QR code and also that I dropped in the chat, you can find our e-learning, and also you should be able to find our documentation on our website, which is very thorough, and we have a lot of documentation on the CompaCom.
Okay, great. So it's pretty well covered in terms of the learning curve. Another one from J. Todd. Do you have ISO 28000 supply chain audits? And I'm not sure which of you can take that one.
No, not
good
me.
Question. As I was addressing the cybersecurity aspect, I would take over that. Not that I know. I don't know specifically this standard. What we have implemented the ISO 27000 standard for the whole information management that we have in our own company, and for the whole design and the whole I would say management lifecycle, including the production aspect of the device, we have the IEC 62443 standard. There is a slight difference between the approach of the industrial and the IT approach. ISO 27001, this is the one that I know is more, I would say, IT focused, information protection, where the IEC is more taking into account the industrial requirement on the device, and the way the device that we design is included in a machine and in a whole plant. So there is a different set of requirements, and this is the one that is accepted for all the industrial requirements. So certainly, I don't know exactly the ISO 20 this standard, but the IEC 62443 is covering a huge as well a lot of this the aspect in terms of cybersecurity. So maybe there are some aspect already covered, and we will need to investigate that if there are specific need for this.
Yeah, well, ISO standard compliance is often very complex, but you seem to be way ahead in that field in any case. Eric Pernet asks, do you have in mind to develop a box like a switch or a router to secure TCP/IP connection without anything else?
It's a it's a good question. There is always an idea to do the things. We have plenty of ideas. The question is really the business case, the business opportunity on one side, and the second thing is how do you manage that? How do you get that applicable in the field? Nowadays, what we are pushing for the industrial segment is to help our customers, especially in the field, to apply the segmentation. We are developing, and we have released different equipment, firewall industrial, or we will release different industrial firewall that are segmenting the lines, that are protecting the lines, that are protecting the machine, and in this way limiting the risk inside of a plant with these devices. And step by step, our target is to protect the device so that everybody is compliant, because this is then something that needs to be integrated in the device anyway after 27 based on the Cyber Resilience Act. But for the existing plans, for the existing application, we really want to establish, to propose firewalls easy to set up, easy to configure, so that the automation specialists can as well protect the different assets which are today not considered as being the highest security.
Aha. I just want to bring up Andreas's own comment here. The link, in case you're watching this in a recording later on, you can see it on screen there, hms-networks.com/network-interfaces-integration. So that will help you. We only have about 3 minutes left, and our next question is pretty broad. So can you give us a quick answer on what are the best practices for maintaining reliable and efficient communication in a highly interconnected industrial environment?
Kurt, you want to address that?
Use CompaCom.
Good. Yes.
There you go.
Very pragmatic answer.
And a nice quick one as well.
Yes.
Yes, I'm sure that, like I said, that's a very broad question, but use
It's very difficult
CompaCom is a good start.
At the end, I think it's a very interesting answer, Andreas, because we take in charge the whole management of all the specific changes and the new requirement in the field. What you have to take care of best practices: first, get your device certified according to the organization, but as well maintain your device to the latest firmware and using CompaCom. And this is where you get really the benefit of this solution and the integration of this solution.
Yeah, if you compare it to using open source software stacks for the protocol on some arbitrary hardware, that isn't so much tested, such as our stacks. Our stacks is written for our hardware, and it's very thoroughly tested, so we know it's robust. It's over 10 million devices out there in the world, and we continuously upgrading and fixing bugs in our software. So if you want to maintain reliable and efficient communication, use CompaCom. We are also visiting Plugfests, where we try out our solution with other vendors' solutions to make sure that they can communicate with each other. Yeah.
The other aspect regarding security and the whole SBOM, the software bill of material that you have to implement with such a module is really simplified. It's one firmware from us. And if you need to, as Andreas said, implement multiple open source or dedicated vendor stack that from different suppliers, it's as well a challenge for such maintenance, maintaining that on our approach. The value is you have one interface, one firmware, and one solution to maintain, and that simplifies a lot all your device lifecycle.
Okay, great. Well, we have just carry on, Kurt. We've just run out of time.
Last but not least, we have on our website tips and best practices for embedding a high-quality communication interface, including a white paper with a guide to your embedded communications to help you to make the right decisions.
Yes, thanks. There is a lot of information on the website. We have to wrap it up now. We're 45 seconds over. I think we can live with that. But thank you very much, Kurt and Andreas and Thierry, for those insightful presentations and for answering all of our questions. We didn't quite get to all of them. We've covered a lot of ground today, from the rapid implementation of industrial communication protocols to the critical aspects of cybersecurity and future-proofing our systems. It was a lot to take in. We didn't get to all the questions, but if you missed anything, yes, I'm looking at you, Alessio, who asked this question, will there be a recording? Yes, it will be on our Elector TV industry. Yes, that's the channel. Look that up on YouTube, and you'll find that there. If you think of any other questions, if you do watch it again or you need more information, you can visit HMS Networks online or the link that Andreas shared with us earlier in this presentation. I hope that everyone found the session as informative as I did. Mastering these technologies not only streamlines your projects, but it also sets a strong foundation for a secure and, thanks Thierry, Cyber Resilience Act compliant and efficient industrial network. So once again, thank you to our special experts here for the presentation today. And thank you all in the chat room for joining us today. Have a great day, and we look forward to seeing you at our next online event.
Thank you.
Cheers.